Hi everyone, here's the 6.2 notes for today. Sorry I can't be there. I will be there tomorrow after school if you have any questions, but let's go ahead and go over 6.1 to 6.2. You have the material today. The only thing we're not going to be going over is quotient, so we are going to be skipping. I will do one example for us, but we'll skip this one to go over. So everyone jump into this. So we're going to be talking about functions. Functions are two different equations and how we're going to be merging them. So today we're going to be merging them through subtraction, multiplication, addition. We're going to try division real quick, and then we're going to be jumping into some more elements of it. So today I'm going to be going through like two different colors a lot. So today you'll see some different colored elements. I want you to take notes on your own. I'll be checking next class. So our first one says to deal with this. So we're going to take g of x and we're going to minus h of x. Just put one right after the other and we'll be done. So here we go. We do 4x plus 3. That's g of x. Then we subtract away h of x, which is 6x. Now, the two things that are alike are this and this. So I simplify by taking 4x minus 6x. That gives me negative 2x plus 3. So the merging of them through subtraction is just combining like terms. Now, when we're going to do multiplication, we're going to do 4x plus 3, which is our g of x, and we're going to multiply it to our h of x, which is just our 6x. So we're going to do the distributive property here through multiplication. We're going to take this one first. So that's 24x squared. Then we're going to take our second one. That's plus 18x. They have two different exponents, so they cannot be merged together. We are done there. Our last one here, we're going to take g of x, and then we're going to add h of x. We're going to put a 2 in the x spot. It's going to replace it, so I don't want to see any x's after we replace the 2. So here we go. Let's do this first. So g of x is 4x plus 3, and h of x is add 6x. So let's go ahead and add them really quick. Like terms say to put 4 and 6 together. 4, 5, 6, 7, 8, 9, 10. So that's 10x plus 3. And now what we're doing is we are going to take this 2 and replace it in the x spot. We're substituting. So this is 10 times 2 plus 3. That gives us 20 plus 3, which is 23. That's our answer. So we're taking our two combinations. We're putting a 2 in there where the x is. So you should see that there's no x in our final answer. Okay, try the right side on your own. I want you to see what you can do. I will work it here for us as well. If you're wondering about what the answers are, so pause the video. Do it on your own. I want to see if you have this. So the answer here is 2x minus 3x squared. The one here is 6x cubed. And the one down here, you should get 8. Now let's go ahead and do it a little slower so you can see it. So here we go. We have h of x minus g of x. So I'm going to take h, which is 2x, and I'm going to subtract away minus 3x squared. Now they have two different exponents here and here, so I can't put them together, so we're all done. Next one, we're going to take g of x and we're going to multiply it to h of x. So we're going to take, what's g of x? 3x squared, and we're going to multiply it by 2x. We did a whole chapter on exponents, so this should be pretty simple. This gives us 6x cubed. We add that 1 that's right here that we don't talk about, and we are done there. Okay, let's try it through addition. So we're going to take h of x, we're going to add g of x, and then we're going to replace x as negative 2. So here we go. We're going to do that. So it's going to be our h of x is 2x. We're going to add 3x squared. So let's go ahead. We're going to replace x with negative 2. So I have 2 x's, so both of them get replaced. 2 times negative 2 plus 3 times negative 2 squared. Please remember PEMDAS telling us to do exponents before multiplication. So here we go. We're going to have, that's going to turn into a 4 because we're going to do this first, then times 3, and this is going to be negative 4. So negative 4 plus 12 lands us at 8. go ahead and take that down. All right, we're going to do this one really quick because we don't actually have this in our topics and I can't figure out how to merge it in, so I'm just forgetting about it. So just really quick, if I had g of x all over f of x, we're calling them different things, and that's perfectly okay. They all have their own name. This happens to be g, that happens to be f, so let's keep going. So we're going to take this, we're going to say f of x is on the bottom, so we have negative 8x plus 3. And then we have 4x squared minus 5. So we've just put g on top and f on the bottom. Now what I'm going to do is I'm going to take negative 4 and I'm going to replace both any x I see, any of them, all of them, any of them. So that's going to give me 4 times negative 4 squared minus 5 all over negative 8 times negative 4 plus 3. Now remember, PEMDAS says that we have 4 times 16, because that's negative 4 squared, minus 5, all over negative 8 times negative 4 is 32 plus 3. So this, our final answer, is 59 over 35. Again, you do not see any of the x's, and that's perfectly okay. Now, when we're asked not in the domain, if we had to merge these through division, I don't want a 0 in denominator. So if I was going to have a 0 in the denominator, I would have to have negative, and let's see, f. I would have to have negative x plus 3 equal to 0. So how do I make the x that would make sure that 0 doesn't happen? So I minus 3 to both sides. I get negative 8x equals negative 3, divide by negative 8, divide by negative 8. So when x is equal to 8 over 3, it's not in the domain. Okay, it's not in our domain. All right, let's go ahead. We just have a little bit more to go over. So we're going to do something. This tends to confuse people, so I'm going to try to describe this as the best I can. So what we're talking about here is we are talking about having the equation of f as the x in our t of x. So we're going to replace and push this of f into the spot right here of x. So what I'm going to do here is I'm going to see if I can color coordinate this. So this is our t of x. So I'm going to write f of x first to be in the center. 2x plus 1. Now I'm going to put that here. So I'm going to put a squared around, negative 2 in front and a negative 2 here. So now that I have that, I'm not going to solve that, because what it is all I'm asking is to say, hey, let's put a negative 2 in that 1x spot and solve. So here we go. Negative 2 times negative 2 squared, plus 1 squared minus 2. So if I'm looking at this, I'm saying, okay, here is the t of x, which was here. And then we have our f of x inside. And what's replaced here is just that negative 2. So let's solve this and find the answer. Negative 2 times 2 is negative 4 plus 1 is negative 3. And then I'm going to square it, multiply by 2 and minus 2. Negative 3 squared is 9. 9 times negative 2 is negative 18. And negative 18 minus 2 is negative 20. Okay, I want you to try the one on your right. So remember, put t of x now in f of x and replace x with a 5. So I want you should get negative 17. So let me show you how. If this is still confusing, that's perfectly okay, but I want you to try this on your own. So here we go. Let's try this. We're going to take t of x as our inside to this guy. So I'm going to do negative 3x minus 3. That's our t of x. And now I'm going to put f of x around it. So I'm going to put the negative that's out front and the minus 5. So as you can see here in our colors, this is that color. Let's pick another color. This is this color. So f of x is on the outside of around the x. And then t of x is inside here. Now let's go ahead and do that negative 5 transfer to that x right here. So I'm going to rewrite it. Negative 3 times negative 5 minus 3, all minus 5. So now I just solve. So again, this is t, the equation of t in the spot of x for f of x. So positive 15 minus 3. 15 minus 3 is 12. Slap the negative on. I get negative 12 minus 5 more, which lands us at negative 17. So go ahead and try it on your own. These are practice problems that we can try. So let's go ahead and move on to our next part. Our next part is this. We are trying to see if they're inverses of each other. And I want you guys to think about inverses as the following. Addition is undone with subtraction. Multiplication is undone with division. Square root is undone with squared. So what I'm hoping for, that if I start at x, if I do something that gets me addition, and then I do it backwards with subtraction, I should land at x again. Does that make sense? I should land where I started. So I'm starting here with x. So let's see if putting one equation inside of the other gets us to that x. So here we go. I'm putting h of x, which is negative x divided by 3, and I'm putting it in the spot of the x here. So negative 3 comes on the outside. This is f of x with h of x on the inside. So here we go. We solve this. Negative 3 over 1 times negative x over 3. A negative times a negative is a positive. And the 3's cancel out, and I'm left with just x over 1, or x. So that worked out. Let's see if the other way works as well. If I take f of x, which is negative 3x, there's f of x, and I'm putting h of x around it. So here we go. This is the x, so I have a negative with, and as you can see here, it's the x divided by 3 with a negative out front. So if I was going to color coordinate this, this is this guy, this is this guy. So I have f of x inside where the x is, and I have the negative 3 division outside. So let's see what we have. If I took this and I said a negative divided by a negative is a positive, and 3x divided by 3, the 3's cancel, and x stays. So when it's asked if these are inverses of each other, yes, they are. And the goal that's telling us this is that I have multiplication of a negative 3 and division of a negative 3. They are inverses. So this is good. That's when we can see that we have inverses. So right off the bat, let's take a look at the second option. And I'm going to see what's here. Well, this is plus 3 divided by 2. The inverses of that are minus 3 and multiply by 2. I can already see that this is probably not going to be the case, but let's prove it. So here we go. We're going to put h of x, which is 2x plus 3. There's h of x, and we're going to put f of the f formula around it. So I'm going to take this as our h. So I'm going to add 3 and divide by 2. So let's go ahead and simplify that. That's 2x plus 3 all over 2. Well, 2x plus 3 is 2, or plus 3 is 2x plus 6 all over 2. Well, I can even simplify here. I can knock out the 2's, and I can have a 1, and a 3. That gets us to x plus 3. That's not x, so I'm not happy about it. Let's try it the other way. If I had f of x, which is x plus 3 all over 2, there's f of x. Sorry, I don't like the way that's written. Okay. And then I have h of x around it. Well, the h says that there's a 2 out front and a plus 3 in the back. So 2 out front and plus 3 in the back. So let's distribute. This becomes 2 times x plus 3 all over 2 plus 3. Well, these are going to eliminate. And now I have x plus 3, which is x plus 6. These are not inverses, because otherwise we would need it to equal x, and it doesn't. So that tells us they are not inverses of each other. Okay, so here we go. We're going to talk about inverses a little bit. You were taught this in Algebra 1, but I'm always curious to see what you retain from that material. So here we go. We're talking about two different elements. So when we're talking about g of x, we're talking about this guy up here. When we're talking about h of x, we're going to be talking about this. So let's go ahead and see what we have for the first one. The first one says that normally I have g of x equals y, but right now I have g inverse. So really this is the y and this is the x. Just like addition and subtraction are inverses, your x and your y can be inverses of each other. So we're trying to see what that means. So here we go. We have here our y equals 2. So then what does our x equal? Well, where our y equals 2 is right here. So that means our x equals -9. So it's just asking for the opposite, to look for the opposite. Now let's go ahead and try the next one. We are going to try this one. So we have to say, how do we find the inverses of h of x? Well, if I'm doing the inverse, I need to switch x and y. And then I need to solve for y. So let's go ahead and do that. Right now, I have y equals x minus 13 divided by 7. That's what I have right now. What I'm going to do is I'm going to switch the x and the y. X equals y minus 13 all over 7. Now I solve. To do this, I multiply by 7, multiply by 7. I get 7x equals y minus 13. I add 13, I add 13, and 7x plus 13. So that's the inverse of this situation, and you should see that. You have minus 13 and division of 7. So in my inverse answer, I should have plus 13, and let me show that here, plus 13 and multiply by 7. So that's my inverse. Now, let's talk about this. If I did one inside of the other, which is what this means, it says apply both of them. Do the x minus 13 divide by 7, and then take it and do the inverse. Whenever we're doing this, I want it to always be like, if I started at -1 and I added something 4 times and then I minused it 4 times, where do I land? I land back at -1. So when I apply the inverses of each other, we just always land back where we started. It should always be there. So let's try this next one. We'll do it together a little bit, and let's see what we have. So here, remember, this is our y, and we're looking for x. So if I'm taking y and looking for x, and this is y is -7, well, y is -7 right here. So that means our x is 4. Okay? Now, here's the cheat way, and this doesn't work every single time, but it's going to work for quite a few of them. This gives me minus 13 and divided by 11. So the inverses of that are adding 13 and multiplying by 11. So let's show it. We right now have y equals x plus 13 divided by 11. We're going to switch x and y. So let's go ahead and do that. We have y equals x plus 13 all over 11. So I multiply by 11, multiply by 11. I have 11y equals x plus 13. I minus 13, I minus 13, and 11y minus 13 equals our inverse. Now, I know that you guys like to see this as a negative exponent, but that's not what it is. This means inverse. Okay, so when it means our inverse, that's what it's asking for. It's saying find our inverse. And as we already established, if I went forward by multiplication of 3 and then I went backwards of division of 3, I land right where I started, which is 1. Okay, so I need us to focus on that inverse element to switch the x and y's. That is our 6.1 to 6.2. Go do your exit ticket. You have our exit ticket. You have your knowledge check. And you have 9% topics. I don't know what's happening there. Topics. Okay, get this done. Thank you. I'll see you next class.